In this video I'm going to illustrate some more ideas behind the concept of a limit. So we've seen sine of x looks like this, and when you combine it with x squared, so sine of x combined with x squared, well, right at this point here, sine of x will be 1, so 1 times x squared, so it would just jump to here. We've seen this point here gets moved up to here, this moves up to here, this will be negative 1, and then when you times x squared it will jump to down here, and this point here will jump down to down here. So as a result you're going to get something like this, and we've already seen this, so I'm expecting you to know that. And we've already seen that when you look at this block, sine of 1 over x looks like this. It squiggles a lot as you approach 0, and dead on 0 it breaks down. So dead on 0 is undefined. So we've already seen that the limit here does not exist. So now when you combine x squared with sine of x, with sine 1 over x, it will get encapsulated within the x squared. So it will look like this. And don't forget, around near the origin it's going to squiggle a lot. So up here with the normal sine block, there is no squiggle. There is no squiggle around here. There is no squiggle around here. With 1 over x, this block here will squiggle a lot as you zoom in to the origin. It will squiggle a lot. The point here is that we've seen that you see the point here is that this thing here, the limit, does not exist, because the whole point of a limit is that it heads towards the same place. It heads towards the same place. It heads towards the same place. See, the limit heads towards the same place. Here it squiggles back and forth. So the limit, that's why the limit here does not exist, because you don't know where it's heading towards. It could, from the right hand side, it could head towards here. From the left hand side, it squiggles a lot. It could head towards down here. So we say here the limit does not exist. But when you combine it with the x squared, this block here gets encapsulated. It's being funneled through the origin because of this x squared. So here the limit, we can definitely say the limit is 0. Here, without it's being encapsulated by x squared, we have to say the limit that does not exist, because we don't know where it's heading towards. Whereas here it's being funneled towards the origin by x squared, so we can definitely say the limit here equals 0. And then down here, hang on, so now the same idea, but now this time it's being encapsulated by 2 to the power of x. So 2 to the power of x looks like this. If you consider the negative version, it looks like this. Combine it with this, it will look like this, and then it will squiggle a lot as you head towards the origin. So here it's being encapsulated, and then it squiggles a lot. So here around this region, as x heads towards 0, we can't say where it's going to head towards. It's not heading towards one. It's not being funneled like the x squared. The x squared is being funneled through one point. It's being funneled through this point here. Whereas here, there's a massive gap from here to here. So we don't know where it's heading towards. So we have to say the limit here does not exist. Okay, here, so here the limit doesn't exist. Here the limit doesn't exist. So another example, hang on. So we've seen this, sine 1 over x looks like this. We can encapsulate it within the circle. So let's say the equation of a circle is x squared plus y squared equals, let's say a radius of 1. We want to extract the positive strand. So rearrange it to make y the subject. That would be y squared equals 1 minus x squared, and then square root both sides, so that would be y equals root 1 minus. The point is that when you square root something, you get the positive version and the negative version. The negative version is talking about this strand here, and then the positive strand is talking about this strand here. So let's discard the negative and consider the positive only. So this is our positive strand only. And then when you combine it with sine 1 over x, it will be like a sine graph, but it's being encapsulated inside the positive strand here. So basically it will give you this thing here. So what is the limit of this as this whole thing heads towards, as x heads towards 0? You see, we don't know where it's heading towards, because as you head through the towards the origin, it squiggles back and forth, and then if you approach it from the left hand side, it squiggles back and forth, and then it could cross over here, it could cross down here, it could cross here, it could cross anywhere. We are unsure. It's unlike x squared. X squared is being funneled through one particular point. Here it's not being funneled. Well, it could cross over anywhere along here, so we have to say the limit here does not exist. So down here, let's combine sine 1 over x with this y equals x graph. So y equals x looks like this. So if you consider the negative version, sine graph will look like this, and then it squiggles a lot around here. So we can say that this here, the limit does exist, even though this block here is undefined as you approach 0. Here it squiggles a lot as you approach 0, but I don't care about the squiggle this time, because it's being funneled through one particular point, which would be 0. So we said the limit, it does exist and it equals 0. Okay. So remember, this alone will be dne. This, if it gets funneled by something that heads towards a particular point, then we say that the limit exists. Here the limit exists, it equals 0. Okay.